Okay, so we have here a series going from 1 to infinity of n over n cubed plus 1. And we have to find out if it's convergent or divergent. Out of all the tests to use, I found the easiest test for this one, for me, is the limit comparison test. And I'll show you how to do it. Well, for any of the comparison tests, you need a series to compare it to. And the series I would choose, the easiest, would be series of 1 to infinity of n over n cubed. And this will simplify down to series of 1 to infinity of 1 over n squared. And see, now this applies to another test, the p-series test. P-series test is the exponent of the series, and for this it will be 2. So p equals 2, and that's greater than 1. So anything greater than, if p is greater than 1, it's convergent. If it's less than 1, it's divergent. So for here, our comparison is convergent. So let me write that down. Series of 1 to infinity of n over n cubed is convergent by p series. Okay, so now we get to the fun part. The fun part is the limit comparison. And the limit comparison is you're going to be comparing these two series from limit n to infinity of the original series over the comparison. So how it looks when we write it out, limit of n to infinity would be n over n cubed plus 1 all over n cubed. So to write that out so it looks, it's easier to deal with, limit n to infinity, it would be n over n cubed plus 1 times n cubed over n. And since these are all, they're multiplying with each other, the n's will cancel out. That makes it easier. So if we rewrite it over here, the limit of n to infinity n cubed over n cubed plus 1. So now this is where, since we can't simplify it anymore, this is where we would plug in the infinities and hope that we get a L'Hopital rule. And that is infinity over infinity. So we plug it in, and infinity to infinity cubed is going to be infinity, and infinity cubed plus 1 is still going to be infinity. So now we apply the L'Hopital rule, and that'll be limit. And in this rule, all you do is find the derivative of the first series and find the derivative of the bottom series. N to infinity. So the derivative of n cubed would be 3n squared, and the derivative of n cubed plus 1 would be 3n squared as well. So as you can see here now, we have the same on the top, same on the bottom, so we don't need to plug in the infinity because this will just simplify even with the limit still 1 over 1, which equals 1. So even if you plug in that infinity, you're still just going to get 1. So the answer is 1. And in by the definition of a limit comparison test, if your limit is positive, so greater than 0, and your comparison was convergent, which it was, the p-series, that means the whole series is convergent. So let me write this, officially write it down that it's convergent. Series of, series of 1 to infinity of n cubed over n, oh man, I'm all messed up right now, n over n cubed plus 1 is convergent by limit Comparison test. And there you guys have it. That is how it's done.